Okay, so if you're tuning in here, you're probably wondering a little bit about DC 12 volt, in this case, power. So I'm going to show you a little bit about how to use a meter, how the charging works, and give you some examples. Basically, a 12 volt battery is a nominal or average voltage. There's 24 volt, there's 6 volt, 8 volt. So 12 volt does not mean the actual voltage per se, it's the kind of average. So the charging system for a 12 volt battery, in this case, is sitting at 12.8, and the range for a battery is going to be about 12 volts, which is near dead, or 40%, something like that. Lead acid. Lithium are going to be different, but this is lead acid batteries. You're going to see somewhere around 11.8 is about the lowest. Absolutely, you want to go any more than that and you start damaging the battery permanently. Then you'll rise up to charging voltage, which is somewhere around 14.4 to 14.8 volts. So we're sitting at 12.8 right now, but if I plug in the charger, and you'll see it start to rise. In this case, it indicates recharge, and it just continually rises. And ideally, you want to get up above 14.4 at least as a bare minimum. This is a sealed lead acid battery, so they're generally going to be somewhere around 14.4 to 14.6 volts to fully recharge. A lot of flooded batteries are going to be more like 14.8, but the battery manufacturer will tell you that. So as you can see, it's cranking it up there, and it's almost full, but it's just going to top it off a little bit. It looks like it reached full, so now it's going to drop it down because it went up there. It says, okay, you know, it's not taking anymore. Now it's going to drop it back to what's called a float, which is usually around 13.5. So if we test the voltage here, we also get 13.5. Now, if you've never used a meter, they're fairly simple in some cases, but this is a nice one, and it tells you real clearly volts DC, volts AC, that's house power, 120 or 240, and then there are other settings we'll show you a little bit, but so you put it on, usually it's going to be a 20 volt scale for DC, and then you should get a reading. 200 you don't use too often, 600 even less, but if you want to read AC voltage, which is your house power, this isn't really about that, but just in case you want to see, just take and stick the probes in there. Normally you don't want to stick things into sockets, but, and you'll see you get about 122.78 volts. So that's AC power. If you want to test your 240, you know, your range or your dryer, you just stick this into the two of those two. That's way beyond the scope here, but just an example. So the main purpose of this video I wanted to show was how you can test things without actually powering. So basically you're testing for continuity. So what came up and prompted This is, I was going to make a wire adapter so I could plug a battery maintainer, which is what this is. Basically just a small charger, charged at about 1.5 amps. And I'm using pieces and parts that I've laying around, so I checked the polarity, which is a positive and negative, to see if they match up. And I found out this happens to be wired backwards from what I have. So, regular power outlet. We can check for what's positive and what's negative with just a wire here. So in this case, let me get this out of the way. You see that symbol there? That's a little diode symbol. There's also that one there, the ohms. You can use that also, and I'll show you both of them. This meter also has a speaker on it, which is kind of nice. So, for example, you want to check your meter. Okay, you hear the sound? You have a circuit, a closed circuit, and it works. So we can figure out which wire is what. Okay, so this one is marked red or positive. It's not that one, it's that one. Okay, so the tip is always positive. So if you were wiring this and it wasn't marked, it wasn't obvious, or you don't know how these plugs work, you can check it. You can check the continuity of it. And before you wire anything, you can always check to make sure you have everything correct. So in this case, you want to check, say, the positive here, and the positive at the other end, whether it's a battery or whatever, or a cord, and you check to see which one's right or wrong. So this is an example of just a little wire adapter I made. I can attach it to a charger and then just stick it on a battery. And this is what I was checking to make sure a lot of these battery maintainers have a plug. Now, if you look at it, okay, this is positive and this is negative. This one, which is the charger, positive and negative, but when you put them together, they're opposite. So if you want to put this on your battery, it'd be backwards. That's why you always want to double check your polarity. So in this case, I'll just cut this and flip it over because everything else I have is all wired this way. This is another one that just came with one of these battery maintainers. And again, it's wired the same way. So when we check the polarity, okay, that's on the side there. Okay, so the other way you can do it, like I said, is using the ohms or resistance. I'll use this one because it's a little easier. All you're going to do, if you watch, it says 1 on this meter, and when you touch it, it'll say either zeros or just a little above if you can get a good connection on it. Okay, basically you want the display to change. Okay, so again, you're checking the continuity between this one. See, if I touch it, it switches, and I touch down here, so that is the same wire, the same connection. And if we touch it over here, you get nothing. Hopefully that makes sense to you. Now, different meters will have it differently. This is one maybe a lot of you might have, just a real cheap one from Harbor Freight. See, this one says DC V, DC volts, DC amps, AC is right there. And then all these other, there you see the little diode symbol, and that will show you the same thing. And you see it switches to 0 or 1, and it goes back to open. So that's a closed circuit. That's an open circuit. So those two are the same, and they should be, because black, and that's the negative. So if you're looking at the socket, you know, the power outlet, this touches the metal on the outside. The center is always positive. So, this is also another type of meter that's kind of cool also, and it's very useful. You can find them on Amazon and elsewhere, but so this one we set it on the volts, and this one you can select DC and AC. And for example, we just touch it on here. That will indicate to us 12.88. So if we want to check the continuity of something, see, we get 0 when it's touching. And I believe it'll also beep for us. Okay, now where were we before the furnace kicked in and destroyed the sound? So we covered the continuity of different testers, meters. This one is really useful, not only because it can do voltage and continuity, has the sound, like I mentioned, so you don't have to be staring at you can just, you know, maybe you're working under the dash of a car or something. And it also has this big clamp here that you clamp on, and that allows you to test amperage. So in this case, you could put it over one of these wires, put it on the amperage setting, and you could read how many amps are running through it. So when would you need to know that? For example, if you were testing a motor and trying to tell if the motor is good or if it's failing and whatever. So the motor would have a the specs on it for how many amps it draws. So you clamp this on around one of the wires and it would read the amps. If, say, the motor is rated for 5 amps, but you see it drawing 8 amps, then chances are that motor is bad and needs to be replaced because it's drawing more power than it's supposed to, which is going to trip breakers, it's going to get warm, it's going to cause all kinds of problems. So this is really useful. I think this was 35-40 bucks. This one is a Craftsman. It's, I don't know, probably 15 bucks, and the others are 7 to 10 bucks. Just in case you don't know much about chargers or battery maintainers, most of these devices will have the specs on them. So input rating, 120 volts, normal house AC power, 60 hertz, that's normal, and it draws about 0.3 amps, okay, and that's at 120 volts. It'll tell you almost all the time 12 volts, again, that's the nominal or average, and 1.5 amp. So this is a maintainer, so it's only going to put out about 1.5 amps. So that's pretty small, pretty slow, but it's great for just keeping a battery charged. This is another one, happens to be a Schumacher, and again, input 120 volts, 60 hertz, doesn't tell you how many amps, but the output 1.5 amps at 12.6 volts, which is pretty low for a charger, but it will work. Ideally, you want a smarter charger or more capable that's going to put you up at 14, 0.4 or higher, and float the battery at about 13.5 volts. So this will work in a lot of cases. It'll keep it charged, but not real good because it's only 12.6 volts. So, for example, we'll show you on the meter this one working. So I marked these. So as you can see, oh, that's right, this one is the backwards one. So we won't use that one because I haven't switched it yet. We'll use this one. Okay, so red to red, plus plus. And this just goes on your battery, or in our case, we'll just go on there. And this one, I don't care for it because it doesn't have any power indication. So it's really hard to know what it's doing, if it's working or not. And you basically just plug it in and you'll see the voltage go up. It says, hey, voltage is just fine. So it'll shut itself off. So that's what's nice about a maintainer, is it's automatic. You connect it to your battery, you plug it in, and you just leave it. Some of them have an LED on there that tells you, it's charging or fully charged. They indicate in different ways. This one, like I said, it doesn't show anything. It's hard to know. You just kind of got to look at the voltage. This other one has a little LED that turns on when it charges, and then it'll turn off when it stops. Okay, so you just plug it in, watch the voltage jump up for a second, and then it just shuts off. So you know it's working. So when that voltage drops down, either under a load which happens with lead acid batteries. You put a load on them, the voltage drops down because of the way they work, and then that will kick on and start charging. So I hope that's educational to you and gives you a little bit of a explanation of meters, how they work, checking your continuity before you hook power up to things. That way you're not blowing fuses. Like I said, if you're going to wire something, to something else, if you're not sure about it, you don't want smoke or, big sparks, you can always check it for continuity. Make sure you have your positive to your positive. However, whatever you're wiring. If you're just making a little cord, you just want to make sure you get the polarity right. You can't always go by the colors. Most of the time with DC, red is going to be your positive, but your negative could be black, it could be white, or who knows, it could be any other color that someone just decided to use. That's why you always want to check with a meter. Check with a device that tells you what it is and what it's doing. This should, if you're working on wiring, one of these meters should be your first tool because you see what it's actually doing. This one is real convenient because it just plugs in, but you don't always have a port to plug into. So get a meter. You can get one of these real cheap, plug it into your car. Plug it in your car. Watch as you start your car, you can see the voltage drop, and then as it starts and runs, you'll see the voltage jump up. You'll see the alternator as it's charging. You'll see your voltage rise, fall a little bit as you turn your blower on or whatever. You'll see what your car is doing. If you have trouble starting your car, maybe your battery's dead. Well, your voltage is going to give you a real good indication. It's not a guarantee, but it gives you an indication of what it's doing. So there you go. If you have any more questions on meters, devices, chargers, whatever, just leave a question, like and subscribe, all that good stuff. If you have a specific video you'd like, let me know. I'll try to make something up. If you're trying to figure out how to do something, let me know and I'll try to help you. Something like this would be a good application if you are in an RV or boat and you're trying to figure out how to charge your start battery from your house batteries and solar, for example. Okay, you could connect one of these pretty easily, so it just tops off your start battery automatically. Doesn't draw a lot of power, and you can put it on timers, and there's all kinds of different ways to do it, but just an example. So another little tip about power supplies, chargers, whatever. A lot of people trying to figure out how to size them. So like I mentioned, this one is 12 volt, 1.5 amp. Your power supply can always be a larger amperage, okay, higher amperage, because that's the capability or the max capacity that it can put out. Your voltage should always match, but your power supply can always have a higher amperage rating. You just don't want to try to power something. For example, this wouldn't run anything that draws 5 amps. It's not going to run a 5 amp motor because it's not big enough. These are just for topping off a battery. That's a real quick overview. You know, a little more in depth than I was going to go, but like I said, if you have questions trying to understand something or whatever, I'll try to keep making a few other, you know, beginner type videos, kind of explain some of this stuff. It's not that hard after you learn a little bit about how it works. The main thing is get a meter of some sort and start working with it. You know, basically, you just don't want the positive and negative to touch. That's where you'll have problems. Other than that, you know, just be careful, and there's lots of videos, but sometimes it seems more complicated than it is, but it's really not. We can all learn. I didn't know all this. I wasn't born with it. I had to learn it too. So if I can do it, you can do it.